we might not have to continue doing that. So today we're going to be able to calculate any period of compounding interest, not just annual, not just quarterly, using the compound interest formula. So I'm going to give you a formula today. And there's one main reason for that, and I'll talk about that in a minute. So how does compound interest help you build towards your financial goals? We talked about that, right? If you get interest upon interest, it really helps with that. The earlier you do it, the more interest you earn. However, Holly Dunn found it difficult to project the compound interest and new balance on her savings account. Potentially because the interest was compounding pretty frequently, and she didn't want to have to do, the same formula over and over and over and over and over. So if we have this first example here, we're just going to jump right in. Elliot Frazier deposited $10,000, which is called a present value because that's how much you presently have, into a savings account, paying 6% annual interest compounded monthly. What amount in the future value, will he have in his account after 5 years? So this is where it would be super annoying to have to do what we did yesterday, right? If we're talking about monthly, how many months are in a year? 12. Over 5 years, how many months are in 5 years? 60. Okay, think about that for a second. We did quarterly compounding yesterday, and I think the most we did was like 3 or 4 quarters, and we had to do the formula 4 times. Could you imagine having to use that simple interest formula 60 times over and over and over? That would get really irritating. And so thankfully, there's this thing called the compound interest formula. Here we go. So instead of having to do 60 calculations, we only have to do 1 calculation. There's a formula. All right, so compound interest formula. All right. The compound interest formula says A is equal to P. We've seen those variables before. And then in parentheses, make sure you write all this down, 1 plus R over N. Close your parentheses after that. And then we've got an exponent on the outside called NT, N times T. All right. We've seen a few of these already. Actually, we've seen all but 1 variable so far. We've seen A, we've seen P, we've seen R, we've seen T. We haven't seen N. That's the one we haven't seen. So what does A stand for? Based on the previous formulas we've seen. What is the value of A? What does it represent? Check your notes from yesterday or the day before, if you don't remember. What does A represent? It's the amount in the account. A is the amount of money in the account. So amount of money in the account. Which basically is the same thing here. What amount, the future value, we can call this the future value because we're calculating the amount of money in the account after 5 years. Of that money compounding every single month for 5 years, which is a total of 60 months. P is what? What does P represent? We saw this in formulas previously as well. Somebody tell me. Oh, wait. What is it? Principal amount. Yeah, the initial amount, the principal. Which is the initial amount. That's how much was put into the account. Okay. We also are going to have, let's see, that's a 1, by the way. So that's just the number 1. It's just part of the formula. What does R represent? What's our lowercase r stand for? Been using this the last couple of days as well. Check your notes from yesterday or the day before. What does R stand for? What does R equal? Yeah, it's the annual interest rate. All right, there we go. I know we know this. It's okay to say it. Annual interest rate. Great. Okay. As a decimal. What about T? What does T represent? In what unit? Years. Cool. Time in years. Nice. So time in years. Now, our new variable today is N. N is the number of compounding periods per year. So number of compounding periods per year. For example, in this first one, we're talking about monthly. So how many compounding periods are there in a year for this first example? If we're going every month, how many times is a compound in a year? Yeah, how many times is a compound in a year if it compounds every month? How many months are in a year? 12, yeah. So compounding periods per year. If we're talking about monthly, it's 12. We're talking about weekly, it's 52. If we're talking about daily, it's 365. We actually did this yesterday, right? We divided by the number of times it compounds per year. So we're going to go ahead and deal with the actual values now. So in this problem, I'm going to go ahead and block this off a little bit so we can keep all of our nice info over here. So all that information is what we're going to be using on every single problem. So what is our value of A in this particular problem? Do we know it yet? Or is that what we're trying to figure out? Do we know A yet? How much is in the account after 5 years? No, we don't. Okay, so we're trying to figure that out. Which means we have P, we have R, we have N, and we have T. So in this problem here, I'm just going to put P up here. P equals what? How much money was invested or deposited? 10,000. Nice. So 10 grand was put into the account. The interest rate, Esteban, what's the interest rate? 6%. All right. As a decimal, what is 6%? 0.06. Yeah, 6% equals 0.06. That's the number we're going to be using for the interest rate. Great. Alexis, how many years are we talking about? 5. All right. And then Miguel, I'm going to have you answer this again. How many times does it compound per year? 12. So N equals 12. These are the numbers we're going to be using within our formula. Then all we have to do is type it in correctly into our calculator and we'll get how much money is in the account. So there's not a whole lot of math we actually have to do. As long as we can plug into the formula correctly and type it into our calculators correctly, we will get the correct answer. So we're going to say A equals the initial amount, 10 grand, multiplied by 1 plus the interest rate, 0.06 divided by 12. And then our exponent will be 12 times 5. So we just substitute in all the values of the variables into the formula. Then it's time for your calculator. So you can do this either way. You can do this on the scientific or you can do this on the graphing calculator. I'm going to use the graphing one because it's a lot easier to see under the document camera. The scientific calculators just have a straight up fraction button on the front of them. It's the N over D button, so that'll be pretty easy to get the fraction in here. So we're going to do 10,000, and then you can do times, parentheses, 1 plus. The fraction button on the side or on the graphing calculators, you actually have to go into a menu to get the fraction on the graphing one. So click on the math button underneath alpha. So the button under the green button, math. Scroll all the way over to where it says frac per fraction. Choose the first one, N over D. And then you'll have your fraction right there. And we're going to have 0.06 over 12. Scroll to the right, close your parentheses, exponent of 12 times 5. That will then give us the answer that we need. And you should be able to type it in exactly the same way on the scientific calculator. And it should give you an answer of, what do we have? How much money is in the account after 5 years? Anybody have it? Hit enter, what do you get? $13,488. How many cents? 50, yeah, and 50 cents. That is how much money is in the account after 5 years. $13,488.50. So that's the first question. What amount will he have in his account after 5 years? That amount. Now we need to figure out the interest as well. How much interest was earned over those 5 years? And remember that interest is just equal to the difference of the new amount versus the principal. So I is going to equal 13,488.50 minus 10,000. So the interest in the account is equal to $3,488.50. So our two answers here, the amount in the account and the amount of interest earned, right there. That's it. Basically, every problem we see today can be answered using this formula. We won't necessarily always be solving for A. Sometimes we'll be solving for another variable within here. But at its base, we will be using this formula pretty much exclusively today. There's our answer. Any questions on this? Any questions on calculator usage real quick? Was anybody not able to get that number when they typed it in? Being able to use this thing correctly is pretty darn important. Also, if you're not at school and you don't have a scientific calculator, and or you don't have a graphing calculator at home, you can always use the Desmos scientific calculator, which works exactly the same as the scientific calculators you have in front of you. So if you go to desmos.com/scientific, you basically have a scientific calculator that you can use anywhere you want. So if you type that in, the function's basically the same as the scientific calculators that are in front of you right now. So if we check down here, we can type in 10,000 times, open up a set of parentheses, 1 plus, we can make a fraction with this A over B button, 0.06 over 12, close that parenthesis. A to the B power is your exponent button, so A to the B power, and then we're going to say 12 times 5, Oops, hang on. Keep it up here. 12 times, wait a second. Come on now. Let's see, parentheses. Let's try it that way. 12 times 5. Yeah, there we go. Is equal to $13,488.50. So it functions almost exactly the same as the scientific calculators and the graphing calculators in the classroom. So if you need to have a nice calculator to use outside of class, Desmos.com/scientific. It is the Desmos scientific calculator. It's excellent. It works just like the calculators in the classroom. So if you don't know, now you know. And if you want to write that down, I'm just going to put this right down here. Desmos.com/scientific. That's your website for a great free calculator. Okay. Questions on this first problem before we start looking at some more? Cool. Turn the page. Yeah. You heading? You okay?
Yeah.
What's up? I don't know. So then you're not really okay. I hope you feel better.
Not big numbers.
Well, yeah, you'll be fine. All right. Okay. I want you to use the formula we just learned to answer these two questions on the top of the next page. So try out 3 and 4. I'll give you 3 minutes on these ones. So take 3 minutes, maybe even 5. We'll check back in at 11:05. How about that? With number 3, our formula should be 50,000 equals 1 plus 0.064 over 4, and then exponent 4 times 10. So how much money is in the account after 10 years? Anybody have that? Are there any questions about what numbers we're using here before we figure out A? Yeah. What's that? 4. Oh, it is compounding quarterly. So yeah, so it's going to compound 4 times a year if we're compounding it quarterly. So n equals 4. So p equals 50, r equals 0.064, n is 4, n shows up twice, and then t is 10. So does anybody have the amount after 10 years? Anybody have A? Type that in. How much money is in the account? If you haven't done it already. Yeah, $94,344.88, it looks like. $344.88. Now, is that the question being asked? Does it ask us how much money is in the account after 10 years? Does it say how much money is in the account? Or does it ask a different question? What's it asking us to find out? What question is being asked? How much interest? Yeah. Now, how much compound interest requires us to know how much is in the account. Even though that's not part of the question, we still need that number. Because the only way we can figure out how much interest is in the account is if we figure out the difference between the current amount and the previous amount. So if it went from 50,000 up to 94,344.88, how much interest was earned? So what's our I value? Yeah, take that number, subtract that number, $44,344.88. Which basically means in 10 years, it's almost double in value at that rate, compounding 4 times a year. So the amount of interest earned is 44,344.88. 94,344.88 minus 50,000 is the amount of interest. That's how much interest was earned. All right, questions on number 3 before we look at the next one. Okay. Now, I'm just going to tell you right now, the next formula has an error, and I want you to see if you can find it. The formula I wrote here is incorrect. I want somebody to tell me why it's incorrect. That's not right. Don't write this down. This is incorrect. Why? No, it doesn't say she has 100,000. It says she wants to have 100,000. So where should the 100,000 go if she wants to have 100,000? Which one? So the I is what we're going to end up solving for. Actually, I don't even know if we need to know what I is. This is a 1, by the way, in the actual formula. I don't think we need to know I here, but she doesn't have $100,000. So this number here is the wrong number. She wants to have $100,000, which means A is going to be 100,000. So my red pen, this is not the correct formula. A is 100,000. We need to figure out what P is equal to. So we're going to write 100,000 equals P times, in parentheses, all this other stuff in the parentheses in the exponent, that's all correct. 1 plus 0.066 over 2 times 2 to the power of 20. All right, we need the value of P. Now, the good news here is that this is a one-step problem to solve. You only have to do one thing to solve this problem. Because right now, the thing we need, P, is being multiplied by all this. How do you get rid of something in algebra if it's being multiplied? Divide it. So we are going to divide both sides by this. We don't really care what that number is. We just have to take 100,000 and divide it by that, which we can just do straight on our calculator. So divide by 1 plus 0.066 over 2 times, what is 2 times 20? 40. Yeah, I'm just going to write 40 here. All right, divide by 1 plus 0.066 over 2 to the power of 40. That cancels on both sides, leaving us with P, the amount that needs to be deposited initially. So P is equal to, here we go, on your calculators, you can just type in this entire thing. Start with a fraction. Whatever calculator you're using, open up a fraction. On the numerator, type in 100,000. On the denominator, parentheses, 1 plus, open up another fraction, 0.066 over 2, close up the parentheses, exponent, 40. We can type it in exactly like we have it on our paper. That's the great thing about these calculators. By the way, the Desmos scientific calculator on your phone does the same thing. You can write that too. So, how much money needs to be invested at 6.6% annual interest rate, compounded semi-annually for 20 years, if she wants to end up with $100,000? Anybody have it? What's our P value? $27,288.97. That's how much money needs to be deposited now to get to an account value of $100,000 in 20 years, compounded semi-annually at 6.6% annual interest. That's our answer. Is anybody not able to get this when they type that into your calculator? That is important. It's also, this problem also emphasizes the importance of really reading the information carefully to know where things go in the formula. Because if you wrote it like this, you get a number that's much, much, much too big. Because we didn't start with 100,000, we're ending with 100,000, which means that A is 100,000, B is what we have to solve for. Questions on number 4 before we continue? Okay. Ooh, you know what? I'm going to show you the next one. And then after the next one, I'm going to have you work on 2 on your own. And then I got to go make some copies because I forgot to print out something for you today that we'll need to use once we get to the final page. So here we go. We won't need it for this next problem though. Any questions on number 4? Good to go right now? All right. Next example. Suppose that you deposit $8,000 in an account that pays 5.5% interest compounded daily. How much interest will you earn in 31 days? By the way, this is probably the most accurate problem we've done so far. Most of the time in accounts, your account will give you an update at the end of each month, but most of the time, we're talking about daily compounding interest. Even if your account only tells you once a month what the value is, it usually compounds at the end of every day, and then they give you an update at the end of every month. So on this problem, how much interest will you earn if you deposit that much? So we've got P, we have R. We definitely have a value of N. So let's talk about what we got going on here. You ready for this? So let's see, we have, so A is what we're trying to figure out so we can get to I. So we need A in order to solve for I. What's our P value here? What is it? 8,000, yeah. Initial amount, initial investment, principal value 8,000 plus, or times 1 plus, interest rate is 5.5, so 0.055. How many compounding periods are there in a year if it's daily compounding? 365. Now, what will our exponent need to be in this problem? Because if we take, think about this for a second. If we take 365 and we multiply it by what? Like, what is our exponent here? What's that? So our exponent is definitely going to be 31, but if we but it has to multiply by the number of years, right? Yeah. Yeah. Yeah, number of periods is 31, right? Yeah. So we're not talking about years in this situation because we don't have years that we're even dealing with, do we? So we can't multiply, we don't have a value of T up here because T is number of years. We're not talking about multiple years here. We're talking about 31 days. So this number up here, by the way, this N times T is always going to be the total number of times that it compounds within the time frame. And so if you're only talking about 31 days, it will compound a total of 31 times within those 31 days. Here, if it compounds for 10 years at 4 times a year, that's 40 times in 4 years. Over here, compounds twice a year for 20 years, that's another 40 times that it compounds in total. The first example we have, if it compounds for 5 years at 12 times a year, that is 60 total times that it will compound. But here, we're not talking about number of years. We're only talking about 31 days. So it's going to compound a total of 31 times. So our exponent is 31. The total amount of times that the amount of money compounds is 31. So that's what we're going to type into our calculators. So we can't really do the n times t variant of our equation here because there's no t, there's no years that we're dealing with. So type it in. What's the amount in the account after 31 days, or basically a month? What does A equal? Yeah, $8,037 and how many cents? 35? 45? Okay. So $8,037.45. So within the first 31 days, how much interest it was earned over those 31 days? Because that's the question here. It's not really asking us how much is in the account. We need to know that, but that's not the answer. The answer is how much interest was earned. So how much interest was earned? Yeah, $37.45. All right. So I want you to use this formula again on the next two questions while I go print some things. All right. Problem number one. Ramona deposited $6,000. So part A is figuring out the amount in the account. So we've got a principal value of $6,000. We're doing 1 plus 0.055. It's compounded daily, so over 365, and we're talking about a total of 25 days. So how much money is in the account after 25 days? What's our value of A? Wait, how much? I don't know if it'll be that much money. I feel like we'll get less than $100 of interest would be my guess. $6,022. Okay, that makes a lot more sense. Okay, so $6,022. And how many cents? 64? Okay. That seems to make good sense. All right. So 6,000. Is it 22 or is it 28? Oh, wait, 25 days. Never mind. 22. You're right. 64. Okay. So we got interest in the amount of, and so for part B, the interest is going to be $22.64 then, right? Cool. All right. Great. That's it for problem number one. Number two. So A, we're looking for the amount first. So we're starting with $6,000 again. That's interesting. This is the exact same interest rate, exact same amount deposited. Just a few more days, 6 additional days in the account. So 055 over 365. So all you have to do is change the exponent from 25 to 31. And this time, how much money is in the account now? $28.09. All right. So basically, another 6 days earns it another $6 in this situation because it's the exact same information otherwise. It's just 6 more days. And then for B, the amount of interest earned then would be $28.09. All right, cool. Those are our answers there. Any questions on compound interest so far? Decent at this point, hopefully. Okay. All right, now that we have that other piece of paper that you needed, got that out in time. Flip the page. I'm glad I remembered because otherwise I would have been scrambling even more. So on May 31st, Dolores Caudle deposited $1,000 in a savings account. It pays 5.5%. There's a lot of 5.5% interest happening here. Anyway, it's compounded daily. On July 1st, how much interest had the principal in her account earned? So that's why we need this table, because we need to figure out how many days are there between July 1st or May 31st and July 1st. So on your table, find July 1. That's day 182. Subtract May 31st. That's day 151. So the way this is going to work is use your table, find out the day number within the year for each of those. So May 31st is day 151. You just find that on the table, day 151. July 1st is day 182. So we're trying to figure out the days between May 31st and July 1st. So days between 5/31 and 7/1. So May 31st and July 1st. And we're just going to subtract large minus small. So 182 minus 151. How many days are we talking about? 31 days. So that is going to be our exponent. So that's how you can use the elapsed timetable. By the way, you could also do a quick Google search if you wanted to. So how many days are between those two dates? It'll tell you. However, this year, it would be what? No, it would be the same because we're not going over February. Never mind. Either way, it's going to be that. This year, it's only different if we're talking about things that go from before February 28th until after February 28th. For this year, you have to add another day because this year's a leap year, but we don't need to worry about that. Okay. So now that we have our exponent value, we can then figure out how much interest had accrued. So, yeah. Figure out how much interest has accrued over the 31 days. We're going to do the same thing we did on the previous question. So we've got A equals, got to figure out A first. Initial amount deposited, $1,000. Multiplied by 1 plus 0.055055 over. Daily compounding is over 365. We're talking about 31 days of compounding. So we are going to now determine how much money is in the account after 31 days. And we only know it's 31 days because we have to use our elapsed timetable. Hello.
Have your attention, please. It's time for the track team to be released. The track members, please come to the attendance office and sign out before you leave.
So how much money is in the account after 31 days? 1,000 and what? $1,004 and how many cents? 68 cents. Cool. $1,004.68. So how much interest was earned? $4.68. There you go. That's the answer. So answer the last two questions, 3 and 4. Need about 3 minutes to get those. Use your elapsed timetable to figure out how many days have passed. This is daily compounding interest that we're talking about now. So work on those last two. And then we'll get out of here at 11:49. So you'll have a little bit of time to get started on your new assignment before we leave. All right. Question 3, let's see, Urani, how many days are between March 3rd and June 21st? Yeah. 110, yeah. So the exponent for number 3 is gonna be 110. Use your lapse timetable, do the subtraction, it's 110. So what you're plugging in here is 10,000, because that's the principal value, the amount that we put in, times 1 plus 5.5%, 0.055, divided by 365 compounding periods per year, to the exponent of 110, because we're dealing with 110 of those 365 compounding periods. How much money is in the account after 110 days on number 3? Anybody have that? Is it still in the 10,000s or has it gone up to 11,000? What are we dealing with? You have it? What'd you get? That's what I get. Yeah. And then did you have any cents after that? 12? Okay. Anybody else? 12 cents? Yeah. Does that sound right? $10,167.12. Yeah, I see a nod over there. Okay. Just nice to always get more than one person agreeing on it. So then the interest would be $167.12. Great. All right. Elijah, how many days are between March 26th and July 24th? Use your table. Find July 24th, pick that number, subtract the number for March 26th. $120 days. There it is. All right. Yeah. 120 days. So here's our formula for this one. 20,000 times 1 plus 0.055 over 365, 120 days. All right. How much money is in the account after 120 days? Who's got that? Anybody have A? $20,364.91. Yeah. So the amount of interest earned in 120 days, which is roughly 4 months-ish, not exactly, but almost. We're going to be earning $364.91 in interest over those 120 days. 4-ish months. In fact, we could do a direct comparison between 4 months versus 120 days. If we used 4 here, and then we changed our denominator underneath here to 12. Looks like 4 months is actually more than 120 days because we get a little bit more money if we compound it for 4 months out of 12. So, cool. Cool. All right. 364.91. All right. So that's it for the lesson here. Let's see.